Whoops, sorry, I was muted. So, hello everybody and welcome. So, we give just a few minutes more for people around the globe, hopefully to connect with us, and then we can start. Okay, so again, hello everybody, welcome. So my name is Roberto Fantini, and I work from Telecom Italia. We are here today for our first webinar, the first webinar of 5G-CARMEN project. So for those of you that are not already somehow familiar with us, 5G-CARMEN is a European funded project that is a part of the wider Horizon 2020 initiative. Its goal is to test on field the fundamental role that 5G technologies can play to support autonomous driving services in real-life scenarios. We will focus for this on a specific motorway corridor, the so-called Brenner corridor, the highway that runs from Bologna to Munich, crossing three different countries, Italy, Austria, and Germany. The project is pretty large. It involves 25 different partners coming from 10 different countries across all Europe that have backgrounds that comes from both the telecommunication and the automotive world, from both the industries and the research institutions. One of the main challenges that we are struggling with, that we are working with here, is to be able to provide these very challenging services also when we are in roaming, also and in particular when we cross the border, okay? As I'm sure everybody of you has already experienced, when you go in roaming, your latency in traditional situation usually increases. And when you cross the border, most of the time, the network falls down for several seconds, sometimes even minutes, okay? Obviously, this is very challenging for us, and it's one of the main things that we are working on, but it's not the only one. We want to show that with the 5G architecture that we have put in place, we will be able to provide challenging automotive use cases also across the cross-border scenario. So the project started on November 2018, and it will end next year in July 2022. In order to be able to showcase the use cases that we have selected in this very challenging situation, we needed to deploy a pretty complex architecture composed of different, we call them functional elements, that needs to interact very closely across networks of different operators. So our goal today is to start these webinar sessions. We will have other of them in the close future. We decided to start with the basic, showing you the concept that I told you before. So which use case we have selected, which are these different elements that are involved in the realization of these use cases, and how they sum up in the final 5G-CARMEN architecture. For this, I will leave the floor to my friend, Andreas Georgakopoulos. Andreas is a solution architect at Wings ICT Solutions. His current research interest studies include 5G, but also beyond 5G services in various domains, including automotive, utilities, infrastructure, and spectrum aspect, along with the intelligent management of dynamic resource in networks. So I hope you will enjoy the webinar today. You can follow the webinar through different channels. You can interact with us if you want, posing questions using the comments on the social channel you are on, and we will be able to see them and answer them at the end of the webinar. So thank you for joining us and being here. And I will now leave the floor to Andreas. Thank you, Andreas.
Thank you very much, Roberto. Good morning, all, also from my side. So, thank you also for joining in this webinar today. So, let me share also my screen in order to start this presentation. Okay, so as Roberto said earlier, this is the main points that we will discuss today in this webinar, which have to do with the project's system architecture aspect, interfaces, but also the use cases that will drive these aspects. So let's start. In the next approximately 30 minutes, we will present the project system architecture, including the specifications of its subcomponents and their interfaces. To this end, as Roberto said earlier, a functional analysis also of specific use cases has been performed by the consortium as well. The use cases that we considered so far in our project, which is running for almost 3 years, have to do with cooperative and automated lane change maneuvers, as well as cooperative and automated in-lane maneuvers. So we will start with the first one. Let's see an overview of this use case and what it is about in general. So here we see the critical points that have to do with the lane change maneuvers, and in general, they will have a big impact on safety, stability, but also the traffic efficiency. By performing such maneuvers in a cooperative and automated way and leveraging also on 5G technologies, we will have low latency communication, and the aspects on safety, stability, and traffic efficiency could be highly improved. Here in the project, we have focused so far on the centralized lane change, which involves vehicle to vehicle and low latency vehicle to network and network to vehicle communication with network recommendation. So that's why we mention this as centralized. We have also the decentralized lane change, which involves vehicle to vehicle and low latency vehicle to network and network to vehicle communication, but without a network recommendation. That's why we mention this as decentralized. And then we have also an aspect on emergency aspects, emergency vehicles that approach. So maybe a lane change or lane keeping may be needed. And we may need, let's say, to have a best estimation of time for the arrival of the emergency vehicle, or as we see here in the acronym EMV, in order to be able to make the necessary actions. Here we see also the main points why 5G is needed. Because as we said, this is a project which focuses on cross-border, especially communication, with the usage of 5G. So here we have, we anticipate the benefits of 5G as in various use cases to be the very low end-to-end latency compared to 4G or previous technologies, the increased capacity due to many connected vehicles that will be around the areas, precise positioning. This is also something that the project has worked a lot through our partners in order to be able to have a higher level position accuracy in vehicles with errors as few as a few centimeters under good conditions, of course. As well as we anticipate through 5G the predictive quality of service to be better, informing vehicles about projected coverage and capacity aspects related to the network along a specified route. As Roberto mentioned earlier, here we focus on the corridor between Bologna and Munich. Then we have also we may leverage, let's say, on the radio network information service, or as we mentioned, RNIS, which provides useful radio access network information. For example, useful location updates, radio conditions for vehicles, etc. All these things are very important for connected and automated driving, and we anticipate that 5G will make this also even better compared to previous technologies. So here we see some of the basic charts that the consortium has worked on and have to do again with the first use case on cooperative and automated lane change maneuvers. On the left-hand side, we see the aspects on centralized cooperative lane chains for in-country scenarios. So here we assume, let's say, that use case takes place in the in-country, for example, inside the corridor in Italy or in Austria or in Germany without changing the border. But of course, since, as we said, the project is focuses mainly on cross-border communication, of course, we have expanded this in order to cover as well the cross-border aspects. Here, we see a lot of elements which are included in this architecture and the basic interfaces which are needed in order to be able to exchange useful messages, as we see here, IVI messages, which is in-vehicle information messages, cooperative awareness messages or CAM messages, DNEM messages, which is about decentralized environment notification messages, or CPM messages about cooperative perception messages. Of course, all these messages have been also standardized through the standard bodies like ETSI. And through this project, we are trying, let's say, to, of course, use standardized procedures in order to realize the use cases, but also try to expand this in order to involve innovative scenarios. Also, one of the main things that we can focus in these charts, and we will see later on as well, have to do with the entities of SLDM here in this specific chart, or as we will see in another one on the VLDM. The SLDM has to do with server local dynamic mapping, which is about aspects which are involve the centralized solution that we discussed, but also the decentralized will be enabled through the vehicle, so the decisions take place in the vehicle part. Of course, there are also specific message brokers that have been deployed in the test fields in order to be able to properly transfer these messages to a specific area, to the broadcast area. So, for example, we use AMQP brokers in order to be able to provide this information to the vehicles moving in a specific area. And of course, there is the UU interfaces, which involve the communication through 5G, but also between vehicles, we may have also the PC5 interface in order to be able also to enable the B2B communication, but also we have the RSU, the radio side units, in order to be able, which are the roadside units, which are on the roadside of the corridor of the highways, which can also use PC5 technologies. Here we see again a chart which involves also aspects as we discussed about the emergency vehicle. So here we may also need to have cooperation messages over UU and PC5 interfaces in order to proceed to lane clearance for the emergency vehicle when approaching. But also, we mentioned on the right-hand side the decentralized, cooperative, and automated lane change maneuver for cross-border here situation, which is also the main focus of our project. And the interconnection, in order to be able, let's say, to enable this cross-border communication, we have a specific MEX, which is deployed in the areas of Italy, Austria, and Germany. And there is this interconnection via this MEX. In this case, we have the geo service, which has been deployed in order to be able to exchange the necessary information and messages that would like to have for the best possible cooperation. And here we see again the main overview of the situation awareness or back situation awareness, which involves again the emergency vehicle, as we see here, the acronym in this slide of the ENV, the warning notification messages that have to pass through the area in order to be able to disseminate this to the wider area and inform vehicles to move along the lane or stay in the lane in case there is specific movement of an emergency vehicle behind them, in order to be able to clear the way and to have the best possible result of automated lane change maneuvers without disrupting the overall traffic, but also with safety and security overall. Then we'll continue with the use cases, and we go to the second one, as we said, which have to do with the cooperative and automated in-lane maneuvers. Here, we assume that there are situations in-lane maneuvers that the vehicles perform mainly longitudinal control and keeps the in-lane lateral control lane-centered, let's say. So here we try to focus on these sub-cases which have to do with in-lane maneuvers based on forward detection. This involves also the cruise control that modern vehicles have. In-lane maneuvers based on lateral detection, prevented lane change. In-lane maneuvers based on backward detection, and this is also related to the emergency vehicle upload. So we have also the fourth sub-case, which has to do with the in-lane maneuvers based on emergency vehicle approaches. The focus here is mainly on unexpected events as required by level 4 of automated driving. And an example, as we said, may be scenario B, as mentioned above. So, for instance, we assume that the level 4 vehicle on the first lane is on the first lane and plans to exit the motorway in a moderate high traffic situation. But we see that and a high number of vehicles may be in front, obscuring the view. A queue or obstacle on the exit lane would require the driver to take over, which means that maybe the driver may decide, as we see on the right-hand side, to keep going straight instead of changing the lane for going to this exit, and probably also go to the next possible exit, so as to, let's say, have a better quality in terms of driving and bypass the queue that would be in front of it. Again, here in this use case, of course, we need to focus on the 5G and in the cross-border, which is the main aspects of, as we said in the beginning of the project. So why 5G is needed in this case as well? 5G would allow to exchange the necessary information. For example, here we mentioned the CAM messages or the cooperative perception messages, CPM, at the same refresh rate as the vehicle onboard sensors, camera onboard, radar, etc., that the modern vehicles have, and have the needed responsiveness, especially to emergency situations, which is a key aspect for the automation level, driving automation level for that we need to have. Moreover, with 5G, it would be able to demonstrate how the VLDM, the vehicle LDM, so the decentralized approach, can be dynamically updated by using information from the server-based approach in order to augment the onboard perception both with improved information about surrounding vehicles and with information from other sources. For example, this may be the road infrastructure, the communication infrastructure, the road operator, or of course the backend, which the backend analysis and provides analysis and processes the huge amount of information that is received from infrastructure, but also the vehicles in the area as well. The outlook would be, and our anticipation, that the SLDM will have the bird's eye view of a local area and could provide the vehicles with all the necessary information related to the driving context, including from road operator backend. Here we see also again the basic architectural charts that have been provided, which show again the main entities which interact, the main functional components which interact and their interfaces in order to be able to have the cooperative and automated in-lane maneuvers, and for the decentralized lane change maneuvers at the in-country level. Again, here we see the different entities that we discussed earlier in the previous use case, which have to do with the server-side LDM, the geo service for the message exchange, as well as the MQB brokers that have been deployed in the near the borders of Italy, Austria, and Austria, Germany, in order to be able to provide the necessary, to disseminate the necessary information to the moving vehicles there in the area. So let's go to the other point, a very important point, which have to do with the project's main system architecture. So here the project has come up with this rather complex image. Because many entities are involved for realizing these use cases. So at the bottom layer, we see, of course, we see here also the interconnection between the countries from Italy to Austria through the Brenner Pass, the A22 highway for those who know the area, as well as from Austria to Germany through the Kufstein border point in order to be able to move from country to country. Then on the other side, on top of these areas, we see the vehicles which at the final pilots have to have the 5G modems for the V2X message exchange, the maneuver management element, which is very important, the most important for the realization of these use cases, as well as the precise positioning that we mentioned earlier, as well as the predictive quality of service. Of course, this is also relies on the various roadside units as well as the sensors, either on board the vehicle or by the highway, in order to measure and monitor the various parameters that are necessary for the realization of the use cases as well as the traffic conditions. Then we have, of course, the base stations. We started with the 4G deployments that were actually there, but we have moved towards the 5G deployments through the installations from our operators that we have in Italy. We have TIM, as Roberto mentioned in the introduction. In Austria, we have Magenta, and in Germany, we have the Deutsche Telekom Group. So through all these, we, of course, there is the core functionality, the service gateway, PDF gateway, and also we have on top of this the deployment of the edge orchestration platforms. I will not go in detail through this slide because I have a next slide which I mention in detail how this edge orchestration works and what they do. So on top of this, we have the edge orchestration platforms which communicates with the vehicles that are moving in the area. And also we have, of course, on top of this, the CIDS backend, which involves also the operators systems. As we said, from Italy, we have the collaboration in the project, the A22 road operator, which helps with these aspects. But also we have the AQP brokers deployed through our colleagues in the project in order to be able to provide the necessary dissemination of messages in the area. So this is again the high-level view of the system architecture that the project defined, and through these all these components and the interaction and interconnection between these, we are able to provide a full use case in order to be able to test and showcase actually the in-lane maneuvers or the change of lane maneuvers as we discussed in the previous use cases. And here, I go also through a brief overview of the high-level functional architecture of the orchestrated edge platform. So this is also an important point of the project. A whole work package has been dedicated to this, apart from this overall system architecture that we showed earlier. And this have to do, as we see here, with the orchestrated edge platform. So the partners here have identified the following layers. From the top, we have the service orchestration level. We have, as we define the NFV SO, NFV service orchestrators, level and provides, let's say, the main interconnection between the border. So there is certain deployments, different deployments of NFVSO in Italy, in Austria, and in Germany. And these NFVSO entities are interconnected through the interface, a specific interface, in order to be able to exchange the needed messages for moving a service. For example, the bug awareness situation for when an emergency vehicle is approaching, for moving a service from one point to the other. Then, of course, it is important to have the communication with the lower level. So we have here a specific interface has been developed, which connects with the NFVSO with the NFVLO. And through the low-level orchestrator, the NFVLO, as we say, we have the ability to be able to communicate with the edge system and the components that are are available on the edge system. So the NFVSO has the bird's eye view in general, and then we have the communication with the NFVLO in order to be able to proceed to the commands below in the system and apparently to the vehicles as well. Of course, we have also the the MEC manager, the MEAO, as we mentioned here, in order to be able to provide the necessary interfaces and interconnection with the components that are available here, in order to be able to realize the different services which are deployed and are hosted in the Mac. For our case, these services which are deployed and hosted in the different Macs, just to remind that we have different Macs in which are hosted in the operators in Italy, Austria, and Germany. So these services they are hosting the NQP broker, the geo service for the messages, as well as the radio network information service, the RNIS. Again, this is, let's say, all the main points that construct the overall edge system. And of course, below this, we have the 5G control plane, the transport network, the actual communication to the cars. So if we want to have a full view of this process, we could assume that, for example, a specific a vehicle is moving in area A, in country A, let's say, and goes near the border. So it needs to notify through the 5G network the necessary components through the MEC. The MEAU also component will be involved. The information will be passed to the NFVLO, and then through the high-level, top-level orchestrator, the NFVSO, we can have the interconnection and the necessary information passed for the service migration towards the second country that the car is moving. And then, of course, the process is that the NFVSO will inform the LO entities, the MEAO, and also through all these things, we will have the opportunity to use the services in the second country that the vehicle will approach in a while during the crossing the border aspect. So these are the basic things that we would like to show today to our audience. And as key highlights, we can mention that we discussed a few things. We introduced, let's say, the basic use cases that we have worked on, which have to do with the cooperative and automated lane change maneuvers, as we saw at the beginning of this presentation, as well as the second use case, which have to do with the cooperative and automated in lane change maneuvers. Then we discussed on the basic system architectural aspects, the main components which involve this rather complex system architecture, but are needed in order to be able to realize this scenario successfully, and of course integrate all the components of the modern 5G architecture also in the automotive domain, and have the ability to use the automotive related systems for the best possible navigation in the environment that we discussed in the highway, and especially near the border, so as to be able to ensure that we have the best possible service continuity as well near the border, because this was, let's say, the main challenge of the call, as discussed in the beginning, to be able to provide this kind of interconnection. And of course, another important part was the orchestrated edge platform. This is also an important part which has the partners of the project have worked a lot. These aspects involved all the necessary components, the main design components development, in order to be able to have also this overall orchestration of resources when moving from country to country. So these are the main points which we would like to discuss today. Thank you very much for attending this first series of webinars, as Roberto said in the beginning. And we would like also to have from you certain questions, feedback, etc. We would be glad to have you again in one of our series. Thank you very much from my side. Please, Roberto.
Thank you, Andreas. Thank you so much. So I see there were a couple of questions. We have one from Ferdinand Eicher about the standards that are implemented in the interface specification. So about that, I think I can answer on that, and then Andreas, if you want to jump in. Yes, so we tried, as Andreas mentioned, to stick as much as possible to existing standards. There is actually a lot of solution already existing for the automotive driving, and obviously in the telecommunication world, which is heavily standardized. So what we relied on mainly is obviously for the 5G connectivity, we are using an implementation of 5G based on 3GPP standard and on a non-standalone architecture that is basically state-of-the-art for commercial deployment of networks. And over there, we provide connectivity to vehicles using the UU interface that is defined in the standard, and using the PC5 interface for the communication from vehicle to vehicle. We also use a lot of solution coming from the ETSI standard. For example, all the messages that Andreas quoted, CAM, DEM messages, they are provided in the ETSI ITS standard. And as we rely heavily on mobile edge computing platforms, as Andreas told, we have deployed them in all the network of the operators. So we have one in Italy, we have them in Austria and in Germany. And from that, we follow basically the ETSI-MEC specification. And we have also seen the pretty complex orchestration architecture that we have deployed. From that, actually, we have done also through the work in 5G-CARMEN, and we were able to contribute to ETSI activities, in particular in the ETSI NFV body of work. So yes, basically, we rely a lot of standards, and we are in the interfaces that we are using, we rely on the specification coming from all these standard bodies. I hope I answered the questions. I don't know if Andreas, you want to add something?
No, thank you, Roberto. I think you covered all these aspects that I had also in mind. So thanks a lot for contributing to this. Thanks a lot.
Okay, then I see another interesting one coming from Sebastian Raubich. Sorry if I messed up with the surname. So basically here, Sebastian asked how we managed to basically solve the issue when you go on roaming. For those of you that are familiar with how mobile networks work when you're on roaming, well, usually what happens nowadays with commercial network is that your traffic is actually routed back to your home network. So if you are an Italian customer that goes in Austria, your traffic from Austria is routed back to the Italian network, so to TIM network, for example, okay? And obviously, this is a major drawback in terms of latency, because it means that your traffic will have to move throughout all these two countries. And it's also complex then to manage the access to the right mobile edge computing platform, because your traffic will have to go back to Italy, and then to Italy maybe has to speak with the MEC that stays in Austria. So to solve this issue here, we decided to lean back again on available standards. In 3GPP, there is actually a solution from that is named local breakout. The truth is that this is something that has been standardized quite some times ago, but it's not usually implemented in commercial network. And the main reason is that technically it's not so difficult to do, but there are a lot of impacts in less technical aspects, like, for example, who does the changing of the connection, who does the lawful intersection of the connection, how do you handle the APN selection, stuff like that. So from 5G-CARMEN being in a research project, we managed to collaborate strictly between operators, and we found ways to implement this local breakout solution taking some liberties, releasing somehow the burden on these less technical aspects. So, for example, lawful interception or charging. We found some shortcuts to solve this issue, since it's not a commercial solution, it's a research project. And with that, what happens with local breakout is that actually your traffic, when you enter the visited network, the user plane of your traffic, so your actual traffic, is handled by the visited network. So it's no longer routed home. So it's no longer routed back to Italy if you come from Italy, but it's handled by the packet gateway and the core network of the Austrian operator, that in this way can easily route the traffic to the proper MAC platform. In this way, what you get is that basically when you're in a visited country, you manage to have the same latency that you have when you are in your home country. I hope I answered the question, Sebastian. Okay, and then I see there is a third one from Godfrey Kiguli, yes. So he asked, what is the expected speed and distance between the cars on the lanes? It's a tricky one. We target to do our testing in a real life situation, as I said. So we are going to do the test on the highway, and we will drive as regular as you usually drive in a highway. Okay, that's our final goal. To be honest, we are still in the testing phase. The project is scheduled to finish next July. And with the COVID situation, we had some issue in actually accessing the road and having the possibility to do the testing on the road. So we are not there yet, but our final goal would be to basically drive on the highway in a regular way, I would say. Okay. And then I think, yes, I see another one. So when are you going to do the testing? I see. So the testing actually started already. We started at the end of last year with the first, in the summer of last year, doing the first test on country. Then we had some small delay due to COVID and the difficulties in actually being able to accessing roads and get out of house. In Italy, we had heavy lockdowns, but basically throughout all Europe. We resumed testing a lot this summer, and this is at the end of the spring and this summer, and we started doing tests also cross-border. So we now have already a lot of test results coming from the country border that will be published in deliverable D5.2. And we started doing the testing, the implementation at the cross-border. We target to have a demo in November for the European Commission. And but then, yes, the actual test campaign is to collect the final result is scheduled for the next year in 2022. Okay. I think it's all. I don't see other questions. So thanks a lot, everybody, for joining us. Please stay in touch. If you want, you can follow us on our Twitter channel, on our LinkedIn channel. We have specific channels for the 5G-CARMEN project. We also have a website that we keep updated with what we are doing. It's 5gcarmen.eu, so it's easy to remember. You can go there and subscribe to our newsletter if you haven't already done so, so that we release a newsletter more or less once every 6 months, so that you can stay, you can be aware of all the listed activity that we've done. We have now in front of us a very interesting period. We managed to deploy all the elements that you have seen in the architecture, in all the operators, along the road infrastructure. Vehicles now are doing tests, and so we are now really entering the phase where we can face real life challenges and see how we can cope with them, and hopefully find important hints and solutions to make the automotive, the automation driving possible as quick as possible. So thank you again. We will have another webinar at the end of October. So stay tuned and have a nice day. Thanks.